everyone, and welcome to the first episode of the Sparked by Mari podcast, a series of conversations that we're hosting between the Mars Advanced Research Institute, also known as Mari, and its partners and collaborators. Today, I'm joined by Dr. Abby Stevenson, Mars's new Chief Science Officer and Vice President of Mari, and I'm also very pleased to welcome Dr. Deborah Crawford, Vice Chancellor for Research at the University of Tennessee. Welcome, Abby and Deborah. It's great to have you. Could you perhaps kick us off by very briefly introducing yourselves to our listeners?
Sure, I'll go first. Hi, my name is Abby Stevenson. I'm Chief Science Officer for Mars and the Vice President of the Mars Advanced Research Institute. Just a little bit about Mari. The mission of Mari really is to connect Mars with emerging science and technology. We aim to spark those discoveries that will help reinvent the future of our businesses and our industry more broadly. But we know we don't have all the answers. We know that collaboration is a key part of our work. And that's why I'm really delighted to be here today with Deborah Crawford.
Thanks so much, Eleanor and Abby. It's great to be here. My name is Deborah Crawford, and I'm the Vice Chancellor for Research, Innovation and Economic Development here at the University of Tennessee in Knoxville. And we're Tennessee's land grant institution. I work with our faculty, staff, and students, thousands of them, to support their research, scholarship, and creative work. And we do this work at UT. We think about doing this work about how we do research that makes life and lives better for communities here in Tennessee and all over the world. And to have that kind of impact, the kind of impact that we want to have, we often collaborate with organizations outside the university, organizations like Mari, who bring to our experts here at the university really important problems that we can help them solve.
Great, thank you, Deborah. And I know a big part of the collaboration that the University of Tennessee and Mari have pursued to date has really been focused on computational science. So, Abby, could you maybe speak a little bit more about the work that Mari does when it comes to computationally driven discovery, before we then perhaps dive a little deeper into the details of the collaboration between the two organizations?
For sure. Computational driven discovery is a really critical pillar for Mari. It underpins almost everything we do in one shape or form. And a cornerstone of that pillar really is our collaboration with the University of Tennessee's National Institute for Computational Sciences, or NICS, as I think it's known locally. And we've been working together with NICS and the University of Tennessee since 2015. And we've been really focused on advancing Mars's capabilities in computational modeling, bioinformatics, and artificial intelligence. And these three different areas of computational science come together in what we call internally, really, the Mars Scientific Discovery Ensemble. And this ensemble is a dedicated high performance computing cluster, which sits at the center of Oak Ridge National Laboratory alongside Summit, which is the fastest supercomputer in the world. So we're really, really proud to be working with world leading experts in this space. And we constantly learn so much from the expertise that comes with this collaboration. It really enables us in Mari to access the world's most powerful supercomputing capabilities. And through the agreement that we have in place with NICS now, we are increasingly able to enable other parts of the Mars businesses to access these capabilities, as we notice that they spread further and further into our organization and the way we do business and the way we conduct research today. And to date, these capabilities have been really instrumental in helping us progress our research efforts in many areas, such as food safety, health and wellness, and we're increasingly seeing these capabilities as a critical part of the way science and technology is developed today.
Yes, so Abby makes some great points. You know, there's no doubt that computational discovery is really important in all kinds of industries, from the insurance and financial sectors to pharmaceuticals to food production and security and many, many others. The growing power of computation made possible by supercomputing and the vast amounts of digital data that are now available to us is really changing the way that we approach and solve problems and really changing how we think about innovation. We use advanced computational discovery tools to not only enhance our understanding of the world around us, but to engineer solutions to some of the biggest challenges we face nationally and globally. And our researchers at NICS have been developing these cutting-edge computational tools and techniques that support research conducted by our faculty, staff, and students, as well as by our collaborators. And we've been doing this since 2007, so 15 years or so. In fact, NICS provisioned and operated the very first academic petaflop supercomputer called Kraken in 2009. So Kraken was a predecessor of the Summit supercomputer that Abby mentioned, and we've been doing pioneering work in this area ever since. When we met Abby and her team at Mars, we were really excited to help them meet their computational needs while also advancing our computational science. The beauty of collaborations like the NICS-MARI collaboration is that they really do create win-win outcomes. MARI benefits from the cutting-edge computational capabilities here at NICS to advance Mars business interests, and NICS faculty, staff, and students benefit from the opportunity to work on real-world problems while also advancing the science of computation.
They have such great names, don't they? Kraken and Summit. Makes me chuckle. Yes. So, Abby, I was wondering Deborah just touched on or started to talk about the collaboration a bit in more detail between MARI and NICS, but I wanted to ask you kind of what have been some of the benefits of the work that you're doing and the work that MARI has been doing with NICS for MARI and the wider Mars business.
And we have a great name there too. So we've nicknamed a key product that we've been working on together with NICS as Marvel, or the longer term name, Mars Advanced Research Virtual Environment Lab. It's a key product that we've really developed together with through the NICS collaboration. And today, Marvel is providing Mars associates with computer infrastructure that is required in our businesses today to carry out the advanced modeling and data analytics capabilities. And we're using Marvel today to test out scientific hypotheses in many different areas. It's a virtual environment that allows us to get a much better understanding of the molecular, particle, fluid, and thermal dynamics relevant to our production operations today. And we're able to investigate these different aspects of our production through Marvel as the backbone for many different applications, from AI to food safety monitoring to simulating our different operations, such as coating technologies, things like that, leveraging Marvel. In many places, like flavor diffusion within gum matrices, looking at efficiency enhancements within our confectionery production, kibble coating in pet care. All of these things are now leveraging the Marvel capability that we've developed together with NICS.
Great.
And our collaboration with MARI and support for Marvel has allowed our researchers to sort of fine-tune their abilities to engage effectively with private sector organizations like Mars to better understand what motivates our industry partners. We've been able to expand our skill sets, both from an operations perspective in deploying, maintaining, and advancing a private cloud environment, and from a computational science perspective through, for example, exercises in containerization, workflow development, automation, and genomics. I think I also have to add that this collaboration has brought together partners from all over the world, the US, Europe, and Asia, and showcased for us how people from different institutions and different cultures can work together effectively on a distributed project.
And Abby, to talk a little bit more about that example, Marvel that you mentioned before, how is Marvel being used by Mars to advance food safety, for example?
Yeah, this is an area that really builds off what Deborah was saying about a truly international collaboration. So here we are bringing our internal experts from the Global Food Safety Center together with the MARI teams, alongside other academic partners from, for example, the University of Cambridge and our own internal Mars Digital Technologies team to use Marvel to and the use case here, and we often refer to the specific real life examples that Deborah was referring to there as use cases where we're applying new capabilities or new technologies to an existing challenge that we have within our business today, which becomes the use case. And in this case, we've been applying Marvel to predict the likelihood of aflatoxins in maize. And maize is a really important raw material for us, and we know that aflatoxin is a significant challenge within our supply chains. And we're bringing together data from many different areas, such as climate data, humidity, temperature, rainfall, all the factors that contribute to aflatoxin formation in maize. And then we've brought that into Marvel and developed a predictive model that enables us to look at the likelihood of aflatoxin development by geography. Um, for those who aren't perhaps aware, aflatoxin, particularly aflatoxin B1, is a type of mycotoxin that forms is produced by certain fungi under certain conditions, and the aflatoxin is particularly toxic when eaten, and that applies to both people and to pets, both important to us and our business. And they can grow in almost all grains and ground nuts such as peanut, and when they're consumed, they really can cause health implications. Um, they can cause stunting in children. They're estimated to cause around 28% of liver cancers globally today, and if consumed over long periods of time, they can really affect the immune system and cause maternal anemia, mortality, and unfortunately affect people disproportionately in poorer countries. So, this is an area that, together with the Global Food Safety Center, we've really been focusing on how we can develop tools that, first of all, help us build resilience within our own supply chains, and then, secondarily, also benefit through the sharing of the capabilities developed, benefit more broadly through society, through sharing this within our different collaborative partnerships around the world as well. So by having access to this data, by pulling together our own internal data and also different climate data, we can make informed predictions about aflatoxin contamination. We can help ensure that the raw materials we purchase are safe, and that we understand more about aflatoxin contamination and the relationship between different growing conditions in aflatoxin formation. And this is just really one example of many that I can think of where working together with NICS through Marvel is really helping us to spark new discoveries, to develop new capabilities in the world of emerging science and technology that enables us to improve supply chain resilience, build better capabilities for the future of our business, and also to share some of those in a way that enables safer food for everyone in the world. So a really great opportunity, and we see this as NICS as a real cornerstone for the future for fueling innovation across Mars. and really helping us deliver against the Mari mission.
No, that's a great example, and it sounds like, you know, Marvel and Mari and Nix's capabilities there are doing some really pioneering work. I wanted to ask you both, how common are these kinds of collaborations, you know, that meet between business and academia, for Mari and for the University of Tennessee?
I mean, I can talk from a Mars perspective. These are relationships that we treasure and nurture for the long term, and we don't have many of them. You know, we have lots of collaborations, but these deep long term connections where we see mutual benefit on both sides are far less common, and we really treasure the collaboration with Nix because of that.
And as likewise, Abby, you know, you mentioned that your goal is to create safer food for everyone in the world. And I can't think of a better example of sort of something that resonates with us as we seek to make life and lives better. Public-private partnerships are, like the Mari-Nix collaboration, are really the cornerstone of our global innovation ecosystem. We're working more and more with industry collaborators as they seek us out to access the expertise that we build in our institution and the types of both physical and cyber infrastructure that we have here. In addition to Mars, we work with other corporate giants like AT&T, Eastman, Siemens, Nissan, and Volkswagen, and many others to solve challenging problems that they bring to us to, you know, to access that research capability and collaborate with our faculty and students. We've also created places on our campus or immediately adjacent to our campus that allow our researchers to work side by side with our industry partners to advance innovation. Our university community loves this because they get to better understand their collaborator needs, you know, by working in close proximity with them. And our industry collaborators love it because they can access our advanced infrastructure and, more particularly, our talent. Our industry partners often love to hire the students that they work with here at the university once they graduate. So we're really sort of creating this symbiotic relationship between our university and our industry partners.
That's great to hear. It definitely sounds like there's lots of exciting momentum and lots to feel hopeful about, thanks to the way that both Mari and Nix are approaching collaborations like these. So looking forwards, I wanted to ask, perhaps to kind of bring things to a close a little, Abby, Deborah, did you have any thoughts on the future of the Mari-Nix partnership and kind of what's next for both of your organisations working together?
Well, I can start, and you know, quite honestly, we had a conversation together yesterday where we're really starting to think about what is Marvel 2.0. So we see a long-term mutual benefit to really continuing to develop this collaboration together, and you know, the world of supercomputing and technology is going to continue to move at a faster, more rapid pace, and it's going to integrate further and further into industry, into businesses, into our lives. And I think the collaboration will continue to deliver, you know, the next generation of technologies and capabilities that we're going to need to keep on the forefront of how this area of science and technology is going to continue to develop. So I look forward to continuing the relationship, to continuing to see how together we can mutually you know, create the next set of discoveries and innovations that will continue to you know, deliver against the mission we both have, which is a very common shared mission. So I really look forward to continuing to see where that goes together.
Yes, and we feel the same way. We're so pleased that Mars chose to work with the university on this project and are really excited to be thinking about Marvel 2.0. Our partnership has really matured into a great example of a successful public-private partnership where both partners really are benefiting from the collaboration. And we're excited to see the ways that Mari and Nix continue to push the boundaries of computationally enabled scientific discovery in the future.